Hello everyone, welcome back to Force Fellow. My name is Ashok. Today in this video, we will discuss about a basic and very important topic in LWC, that is decorators. I will divide this video in two parts. In first part, we will discuss each decorator in detail with examples, and then in second part, we will cover all the interview questions related to decorators. Okay? And as I said, this topic is very important, especially wire decorator for everyone. Even if you are a beginner or experienced, or you are someone who is preparing for interviews. So I'll be explaining everything in detail, and yes, might make this video a bit long, but trust me, by end of this video, you will have no regrets and will learn lots of new things. Alright? Now, let's start first part of this video and discuss about what are decorators. So we can say, decorator is a special type of function that adds some superpower to an existing method and property without directly modifying the original code or original method. What does it mean? It means decorators are predefined special functions provided by framework, and if we add those functions with our properties and methods, then our methods will have additional capabilities. So in nutshell, we can say decorators are a special type of functions and they are designed to apply additional features with properties and methods. So to better understand this definition, let's see how decorators work. So decorator takes a function or property, then modify its behavior and return the modified version, and that modified version will have additional features or improved behavior. For example, let's say this is our function or property. Now if we add decorator with it, then our function will be wrapped under decorator. Which means at runtime, our function will have this decorator capabilities as well. So that's why in definition, we said that decorator adds additional capabilities with methods and properties. Now I think you have fair understanding about what are decorators and how they works. So let's move ahead and see what all types of decorators we have in LWC. So LWC provides three built-in decorators: track, API and wire, where track helps to make properties reactive, so their changes can be observed and re-rendered on UI. And API decorator helps to make properties and methods as public, so they can be accessed by parent components, and these public properties will automatically become reactive as well. And wire decorator helps to call Apex method and LDS wire adapters to get data from Salesforce database and store data into client-side cache. We'll discuss more about each decorator in coming slides. Alright? Now, you might be thinking that can we create our custom decorators, or can we write our common logics in a decorator method and use that method with other functions? Yes, if you are thinking so, then you are right. Because the main advantage of decorator is that we can increase code reusability in a modular way. But unfortunately, in LWC, we can't create our custom decorators. Though we can create in other JavaScript frameworks like in Angular, React or in Vue.js, but in LWC, currently this is not possible. I mean, in JavaScript, this is possible to create custom decorators with the help of TypeScript, but I think as of now it is restricted by Salesforce in LWC. Okay? Now, we all are clear that in LWC, we have three predefined decorators: track, API and wire. And we can't create our own custom decorators. Alright? Now, let's discuss about track decorator in detail. So, as I explained, track decorator marks properties as reactive. What does reactive means? It means when value gets changed in a property, then that updated value should automatically reflect on all the places wherever we have used this property, like anywhere in getter properties or in HTML file. So if we used a trackable property on HTML, then that component will automatically re-render in case of value change to keep UI up to date. This is called reactive behavior. Now, you might be thinking how we can use track decorator or how we can make a property reactive. So if you want to use any decorator with properties or methods, then before their declaration, first we have to add symbol, then decorator name. For example, let's say we have a context property, and if you want to make it reactive, then before this property name, we have added @track. Okay? So this is how we can make properties reactive in LWC. But Salesforce introduced a major update, and as per that, track decorator is no longer required to make properties reactive. All the properties will by default reactive, which means we don't additionally need to add track decorator with properties. So now, if you are working on a LWC component, then track decorator is not required to make properties reactive. Properties are by default reactive now. Alright? Now, you might be getting one question in your mind that if properties are by default reactive, then what is the use of track decorator? Is it still required anywhere? Then answer will be yes. In one use case, track decorator is still required. That is, to observe changes in objects properties or in array elements. I mean, still there is one use case we have for track decorator, that is with non-primitive data types. I mean with objects and arrays. So if we directly assign new value in any property, then that will be observed by framework. Like here we are assigning demo value in username property. So it will be automatically observed by framework even without adding track decorator as well and updated on UI. And here in this second example, we are assigning a new object into full name property. So it will also be observed even without track decorator. But what if we update something in object properties instead of directly updating main object? Like here we are not directly updating value in full name object. Here we are modifying last name property of full name object. Right. So in this case, changes will not automatically observed by framework. Framework will only observe when property value is directly get changed. If we are updating something in object properties, then that will not observed and update on UI. And same thing will happen with array as well. I mean, if we directly update array reference, then that will be observed, and if we push new item like this, then that will be not observed and even not automatically update on UI. So in case of object or array properties, track decorator is still required. I hope this point is clear to you, but still let me repeat it again. If we directly assign new value in component properties, then track decorator is not required. But if we update something inside object properties or array items, then their changes will not directly observed by framework. So in that case, track decorator is still required. Alright? Now let me show you all these things practically. For demo purpose, I already implemented few examples in my org. So let me show you all these things in real time. Here I have 4 examples. I think first let me walk you through code, then we'll see in browser. Here let's open track decorator example. And in this example 1, we simply have a counter property with default value 0. And in that button click handler, we are simply increasing counter value by 1. Now what will happen? Whenever we'll click on that counter button, then this handler method will get called, and here we are simply increasing counter value by 1. And I already mined this counter value here in HTML. Let me show you that too. Here it is. So on clicking of this button, this handler method will get called, and inside this handler method, we are simply increasing value by 1. Okay. Now let's see that in browser. Okay. You can see value is getting updated when I click on this button, which means reactive behavior is working fine even without track decorator as well. You can see here we don't have track decorator added with this property, right? I hope this first example is clear to you. Now let's see what we have in second example. Here we have a property and assign an object inside this. So it becomes an object property, and under this object we have a counter property with default value 0. Now under this button click handler, we are assigning new object inside this object property with incremented counter value. You can see here we have used assignment operator, and this is how using curly braces we can declare a new object in JavaScript. So at the end, here we are assigning new object inside this example2 object property. Okay, and here in HTML, this is how we have used this property example2 obj.counter, which means that counter value should be visible here. So let's check in browser. Alright, you can see counter value is increasing on clicking of this button. Now, if we see third example, then here also we have declared an object property with counter value 0, but inside this button click handler, we are not directly updating object. Here we are updating object's counter property. In example 2, we are directly updating main object property, but in example 3, we are updating object's inner property, right? So let's check in browser what will happen. See, value is not updating on UI, although value is updating in property, but not reflecting on UI. Let me show you in browser inspect window. See, here we have 5 in object 3 counter property, but on UI still we have 0. So now the question is why this is happening. This is because there is a limitation to the depth of changes. I mean, if we update objects inner properties or array items, then those will not directly observed by framework. But if we update main property instead of inner properties, then it will be observed as we have seen in example 2. See, in example 2, we are assigning new object inside main property. Which one is the main property here? This example 2 obj. But in example 3, we are not directly updating anything in example 3 obj. We are updating inner property value, that is counter, right? Now to update inner properties on UI, every time we can't go with this approach and reinitialize whole object, because that will remove other properties, right? So now if you want framework to observe inner property changes and update them on UI, then we should use track decorator. Like here in example 4, we have added track decorator with object property, and similar to example 3, we are increasing counter value by 1, which means for this property, framework should observe inner property changes as well and automatically update them on UI. So let's see what happens. Alright, you can see value is updating on UI even without updating whole object, right? This is because of track decorator. So in nutshell, if we are working with object or array properties, then still we should use track decorator. And from LWC module, we have to import it like this. Okay? I hope now it's clear to you what track decorator is and when we should use it. Alright? Now let's move ahead and discuss about API decorator. So as discussed, API decorator makes properties and methods as public. I mean, whatever properties and methods we declare in component, those are by default private. It means those can only accessible in current component bundle. I mean in current components.js or in HTML file, right? Because those are private. For example, let's say here we have two components, parent and child. In child component, we have two properties, first name and last name, and one method, full name. Now let's say in first name and in last name property, you want to pass data from parent component, then directly this is not possible. Why? Because as discussed, properties and methods are by default private, so we can't access them in parent component and set value from there, right? Now to access these properties in parent component or to set value from parent component, we have to make them public, and for that we have to use API decorator. Okay, so in nutshell we can say API decorator helps to expose properties or method to outside of current component for data communication and for other purpose. Alright, now let me show you how to use API decorator with examples. Here we have two components, parent and child. In parent component, we have two text boxes. Now let's say on clicking of this submit button, we want to pass these text boxes data into child component and show here like. Alright, now here in child component, you can see 4 and 5, which means these text box values passed to child component, and this is a parent to child data communication scenario. I already created a separate playlist to explain whole data communication in LWC. which covers all the data communication scenarios like parent to child or grandchild data communication, and child to parent and grandparent communication, and communication between non-related components. So if you want to learn data communication in detail, then you can refer that playlist. Link is available in description. Okay. Now let me walk you through code how this is working. Here in parent components HTML file, we have two text boxes to enter number 1 and number 2, and here we have submit button, and with this submit button we have defined this handler method and created this handler method here in JS file. And here also we have declared two properties to hold number 1 and number 2, and here in submit click handler we are reading those text boxes values using refs and assigning into these properties. Refs is recently introduced in LWC, which helps to access HTML elements in JS file without using query selector. If you want to know more about refs, then you can refer my another video. Link is available in description. Or if you want me to create a separate video on this, then do let me know in the comments. Okay. So now in these properties, we will have text box values, right? Now if you want to pass these values into child component, then first we have to create public properties in child component. So here in child component, we have created two properties, number 1 and number 2. And to make them public, we have used API Decorator, which means now from parent component, we can pass data in these properties, or we can say now these properties can be accessed in parent component. And here in parent component, we have two ways to pass data into those properties. First is using declarative approach, where we have to pass data as an attribute with child component markup like this. Here in parent component HTML with child component markup, we can write public property name in kebab case, and then here we can pass value static or dynamic. Static means we can write any value here in double quotes like this, and dynamic means we can bind any property here like this. In child component, our property name is number 1, where O is capital. So when we convert it into kebab case, then capital letter will convert into small with hyphen. That's why here we have written number -1 as a attribute and bind number 1 property, which is available in our component.js file, this one. Now this property value will automatically pass to child component and bind into number 1 property. And similarly we are passing number 2. Alright. And now properties are by default reactive. So when value gets changed here in parent component, then it will automatically update in child component as well due to reactive behavior. Okay. So this is how using declarative approach, we can pass data in child component public properties. Alright. Now if we talk about second approach to pass data in child public properties, then that is programmatic approach. I mean here in JS file, we can directly access child component public properties and assign value like this. Here using refs, first we are accessing component element. I mean here with child component markup, we have used LWC ref directive and assigned child demo as value. And now here in JS file, using refs, we are selecting child component element, and then using this element, we can directly access public properties. So here we have written this.refs.childdemo, then property name, that is number 1. Here in programmatic approach, property name should be exactly same as child component. I mean in this case, no need to convert it into kebab case. Alright. So this is how in parent component JS file, we can access child component properties and assign value. Now you might be thinking that can we read value from child component properties in parent component? Like let's say here we want to read value of any child components property like this number 2, then answer will be yes. In the same way we can read value as well. Like let's say you want to print in console, so let's write console.log. Like this. Okay. So here key point is using child component element, we can access any public property in parent component, and then from here we can easily read and assign value. Alright. So this is how we can get and set value in child component public properties from parent component. Okay. Now, next question you might be getting in your mind that can we call child components method into parent component? Then answer will be yes. Similarly, we can call child component methods as well. But again, the condition is that methods should be marked as public using API decorator. For example, here in child component, we have a multiply method which multiplies number 1 with number 2 and assign value into this property. And here you can see we have used API decorator with this method, which means this method will act as public method. And here in parent component, we have a multiply button. Now let's say on clicking of this button, we want to call that child component method. Then first we have added onClick listener and assigned this handler method and also created this handler method here in JavaScript file. Now here in this handler method, first we have selected child component element and then called multiply method. So simple, right? I mean, with the help of refs, first we have selected child component element, and now with this element we can access any public properties and methods. Alright. Now let me comment out this first approach and show you in browser. If you are assigning value programmatically, then no need to add child components properties as a attribute. So that's why here we have used only refs directive. Okay. So now let's deploy this component. Now here let's enter something in these text boxes and click on submit. You can see value here in child component, which means we have successfully accessed child component public properties into parent. And in console, you can see 5 here, which means we are also able to read value from child components public properties. Okay. Now let's click on multiply button. We can see 25 here, which means we have successfully called child components public method from parent. Okay. So this is how we can use API decorator in LWC to expose public properties and methods to parent component. Okay. Now let's move ahead and discuss about Wire Decorator. So in LWC, with the help of Wire Decorator, we can read data from Salesforce server either by calling LDS wire adapters or by calling Apex custom methods. Here LDS means Lightning Data Service, which is a data service created on top of user interface APIs, and this helps to work with Salesforce data without writing custom Apex. I mean, it provides many built-in methods to work with Salesforce data, so we don't need to write custom Apex for basic functionalities, and those methods are called wire adapters. If you want to know more about LDS, then do let me know in the comments. We'll create a separate video on this. Okay. Now, with the help of Wire Decorator, we can call those adapters to get Salesforce data. And in case if our requirement cannot be fulfilled by LDS wire adapters, then we can create an Apex method with Aura enable cacheable true annotation and call that method in LWC using Wire Decorator. Now, one question you might be getting in your mind that can Wire Decorator only helps to read data, or with the help of this can we perform DML operations as well? Then answer will be no. With the help of Wire Decorator, we can only read data from Salesforce servers. We can't use it to perform DML operations. Alright? I think now it's clear to you what Wire Decorator is. So now let's move ahead and understand how to use it. So if we talk about first step to use Wire Decorator, then that would be importing decorator method from LWC module. I mean, if you want to use any decorator in LWC, then first we have to import that from LWC module. So if you want to use Wire Decorator, then first we have to import that from LWC module like this. And then as a next step, we have to import adapter ID from adapter module. Here adapter ID is nothing. This can be a method of Apex class or LDS module, which we want to call through Wire Decorator. So whichever method we want to call here using Wire Decorator, that method also we need to import here in component. Now, after importing that method, this is how we can use Wire Decorator and call method. Here, first we need to write @wire, and then here we can pass two parameters. First is adapter ID or method that we want to call. In other words, we can say here in first parameter, we have to specify a method that we want to call to get data, and this is a required parameter. Okay. And in second parameter, we have to pass additional details or parameters. Those are required in this adapter ID. For example, let's say we want to call getRecordWire adapter, which is available in LDS module. So as an adapter ID, we will pass getRecord, and which particular record we want to get, that record ID we have to pass in this second parameter. Okay. Now at last, here we can write a property or function. What does it mean? It means we can use Wire Decorator in two ways, either as a property or as a function. If you simply want to read data from a method and don't want to do additional operations after fetching data, then we can use wire as a property. But if you want to do additional operations after getting data, then we have to use wire as a function. Okay. Now let me show you all these things practically. Now let's say here we have a requirement to get and show accounts list in a LWC component like this. Here we have a text box in which we can enter search text, and on clicking of this search button, our component will make a request to server and fetch data according to this search text. For example, here let's enter age and click on search. Now here you can see only those account records which contains age in name field. Okay. Now if we talk about what we have to do to achieve this requirement, then first of all we have to create an Apex method which can help us to read data from Salesforce database, and then we'll call that method in LWC component. Here you might be getting one question in your mind, that if you want to read data from Salesforce database, then do we always need to write Apex method? Then answer will be no. It's not always required to write Apex custom method to get data. We can use LDS wire adapters as well. But if you have a requirement which cannot be fulfilled through any out-of-box LDS adapters, then we have to write our own Apex method. And here our requirement is to read account records without passing record IDs. And as of now we don't have any out-of-box LDS adapter or method that can help us to achieve this requirement. That's why here we have to create an Apex custom method. So here I have created an Apex class which have one method, get accounts. Now if we talk about this method, then this is a public static method which returns list of accounts and takes one input parameter, that is search string. And here first we are checking is search text is empty, then executing this simple SQL query without where condition, which returns account ID, name and phone. But if we have something in search text, then in SQL query we are adding where condition with like keyword on account name field, which means this query will return only account records. Those name contains search text value, and finally returning accounts list from this method. Okay. Now if you want to call this method from LWC or Aura component, then this method should be annotated with Aura enable annotation. Without this annotation, we won't be able to call it from client-side frameworks like from LWC or Aura. In our case, we want to call it from LWC. So here we have added this Aura enable annotation. Now the question is, when and why we should use this cacheable true with Aura enabled? Then answer is, it is required when we want to call an Apex method in LWC through Wire Decorator. Only Aura enable is not sufficient in that case. So here we can say, if you want to call an Apex method through Wire Decorator, then that method should be marked as Aura enable and cacheable true annotation. Then only it can be called through Wire Decorator. This is the prerequisite. Alright. Now let's see how we can call this method from LWC component. So if you want to call any Apex method in LWC, then first we have to import that method on top of component class from Salesforce Apex module like this. Here we have to write Salesforce, then Apex, then class name, then with dot we have to write method name. Okay. Now let's see how we can call this method through Wire Decorator. So if you remember steps which we discussed to use Wire Decorator, then first step was to import wire method from LWC module. So we have imported it here, and second step was to import adapter ID or method. So we have imported our Apex class method here. Okay. Now after importing adapter method, this is how we can use Wire Decorator to call Apex methods or LDS adapters, where simply we need to write @wire, and as a first parameter we have passed our Apex method that we want to call. And here our Apex method requires such text as input parameter. So whatever input parameters we want to pass this adapter method, those we can pass as a second parameter like this. Here first we need to add curly braces, because in Wire Decorator second parameter should be an object. Now here first we can write parameter name that our method requires. Like in our case, our Apex method requires such text as input parameter. So here we have written such text, and after colon here we can pass value static or dynamic. Static means we can write static text like this. Now this text will be same during whole component lifecycle, but in our case we can't pass such text statically like this, because we have a search text box on UI. So user can enter any value there and that should be passed here. But in many scenarios we have to pass static value as well, right? Now let's say in our case we want to pass value which user entered in text box, and that entered value we have stored in this search text property on search button click. Okay. Now if we want to pass this property value to Apex method, which means we want to pass dynamic value to calling method, then what we can do for that? So if we want to pass dynamic value, then we just need to add dollar with property name like this. Now what will happen? Whenever user will click on search button, or we can say whenever value will get changed in this property, then this Wire Decorator will automatically call this method again and fetch data according to new parameter value. Okay. So always remember, if you are going to pass a reactive variable as input parameter, then we should use dollar as a prefix. That's how Wire Decorator will also work as reactive and refresh data on parameter value change. Alright. And this second parameter is completely optional. I mean, if you want to pass additional details to calling method, then only we should use it here, else we can directly call method like this. Okay. So this is how we can use Wire Decorator to call Apex method or LDS adapter. Now as discussed, this Wire Decorator can be used in two ways, either as a property or as a method. In this case, we have used it as method. Why? Because here we want to do some manipulation after getting response. Like here after getting accounts list, we want to add one more property with account URL just to open account record page on clicking of name. I'm doing this just to create a dummy scenario. But in your case, if you have any requirement where you need to work with method response, or you want to perform some logics after getting data, for example, let's say you want to hide loader once we get data, then we should use wire as a method. But if you don't want to perform any logic here in JS file after getting data, then we should use wire as a property like this. This is simply a property, right? Here we can't perform any logic after getting data, but in wired method we can perform, because wired method work as a callback. Okay. Now the question is what this Wire Decorator will return, or how we will get and use method response here. So if you are using wire with property, then framework will return two properties, data and error. In data property, we will get actual data which our method returns, like accounts list in our current use case. And if any error occurred while fetching data, then that detail we can find in error property. Now the question is how we can access data and error property if we are using wire as a property. For example, let's say you want to access this wired property data in this search button click handler, then we will write something like this. Okay. And similarly we can access error property. Alright. And if you are using wire as a method, Then also framework will return two properties, data and error, but inside an object. Like here we have written result. This will be a object. Now inside this result object, we can find data and error property. Okay. And at many places, you may find void method written like this. This is also same thing. So don't get confused. Okay. I think now it's clear to you how we can use Wire Decorator in LWC. But again, let me summarize all these steps. I feel that will help you to remember. So if you want to read data in LWC using Wire Decorator, then first we have to import wire from LWC module. Then we have to import adapter or method which we want to call. And then we can use wire as a method or property. And in response, Wire Decorator will return two properties, data and error. Alright. Now to complete this use case, here in wired method, we have checked if there is something in result.data. If yes, then we have used JavaScript map method to iterate over each item to add new property. If you want to know more about all the JavaScript methods which are often required in LWC, then do let me know in the comments. We'll cover them in a separate video. Okay. And here after adding new property, we have assigned it into accounts list array, which we have declared here. Now here in HTML template, here we have used lightning data table to show accounts list, and in data attribute passed accounts list array, and in columns attribute passed columns property, which we have declared here, and this columns constant we have created here. Okay. So this is how we are completing our use case in LWC component using Wire Decorator. As of now, we have gone through what Wire Decorator is, how we can use it in LWC components, and what or how it will return data, right? But still we have few open questions like when it will get called and how it works and why we should use it and many more. So let's move ahead and address them one by one. And first start with when Wire Decorator will be called. So we used to write Wire Decorator code directly under the root of component class. I mean, we can't write Wire Decorator inside any component lifecycle hook or inside any method. We can only write it in component class root. Like here you can see, we are not writing it under any component lifecycle hook or any method, right? That's why the biggest question is when it will be called. Now, if we talk about answer of this question, then we can say Wire Decorator will automatically called by framework whenever the component is connected to the DOM or whenever associated dynamic parameters value gets changed. Which means Wire Decorator will mainly get called in two situations. First is when component is connected to DOM, and second is when dynamic parameter value change. I mean, if you are passing dynamic parameter in Wire Decorator, like here we are passing search input text. So now what will happen? Whenever value gets changed in this property, then framework will automatically call this wired method again. Let me show you this thing in browser by adding breakpoint. Here, let's open inspect window. Now let's open sources tab. Here, let's press Ctrl P and enter our component name and select this JS file which is available in module C folder. Now let's scroll down and find our decorator method. Here you can see our decorator method. So let's add debugger by clicking on this line number. This is one of the best debugging technique we have for front-end developers. If you want me to create a separate video to explain all debugging options for LWC component, then do let me know in the comments. Alright. Now let's enter something else in this text box. Let's say Acme and click on search. Alright. You can see execution is paused here under this wired accounts method. Why? Because on search button click, we are updating text box value in this property, and here in wire, this same property is used as a dynamic parameter. And as discussed, whenever value gets changed in dynamic parameter, then framework will automatically call adapter method again. Okay? I think this scenario is clear to you. Like on dynamic parameter value change, framework will automatically call Wire Decorator. Well, now let's see another scenario. What will happen on component load? So let's refresh this page. you can see execution is paused here under this wired account method, which means on component load, Wire Decorator automatically get called, right? Now let's check what we have in this result.data property. Alright, here we can see undefined. Let me check in error property as well. Here also we can see undefined, which means we don't have data in both properties. Now let's click on this play button. Again we can see debugger on wired accounts method. And now if we check data property, then this time this is not undefined. This is a proxy array. Now if we want to check what we have in this array, then we have to convert it into a string like this. Now we can see account records here, which means in second time we can see data in data property. Now the question is, why this decorator get called twice on component load? Is this a correct behavior? Then answer will be yes. This is a normal behavior for wire decorator. I mean, it will always get called twice on component load. First time it will call right after constructor, and second time it will call after rendered callback lifecycle hook. But again question is, why twice? So the reason behind this is, using wire decorator, we can call Apex methods or LDS adapters, and they generally execute on server. It means they may take time to execute, right? Now, do you think LWC should hold rest of the component loading and wait until it gets data from server, or it should keep loading rest of the code of component? And in component also, we may use wire properties anywhere in code, like in getter properties. Now, if LWC will hold rest of the component execution and wait until wire decorator gets data from server, then it will be a performance issue. And if LWC will continue execution, then this code will throw an error. This is because initially this account will be undefined, so we can't navigate to this data property, right? Now to overcome this problem or to initialize the variables, Salesforce made wire decorator async. So in first call, framework will initiate data request and return a placeholder or blank object without data. It helps to set up the necessary structure and component even if the actual data has not been fetched yet, and also helps to avoid potential issues with undefined variables, right? And second time it fires immediately after it receives data or generate an error. Alright, let me summarize this again. The question was, why wire decorator get calls twice on component load? So this is because in first call it returns a placeholder object without data. Why? Just to make sure that we don't get any issue due to null or undefined variables. This process also helps in component structure rendering, okay? And second time it fires when framework gets data, which means in first call we will always get undefined in data and in error property, and in second call we will get data if everything is fine, else we will get error in error property. Alright? Now, next question you might be getting, what will be the order of execution of wire decorator with lifecycle hooks? I mean, when this wire decorator will call first and second time. So always first constructor will call, then wire decorator will call and initiate a data request and returns empty object. And then component execution will move forward and call connected callback lifecycle hook. And then render and rendered callback will call. And then whenever wire decorator get data from server, then it will call again. And after that, render and rendered callback will also get called again. Alright, I hope this point is clear to you now. Like we can't call wire decorator externally. Framework will automatically call it on component load and on dynamic parameter value change. Okay, now let's move ahead and see why we should use wire decorator to fetch data. Don't we have other way to fetch data from Salesforce server in LWC? Then answer is yes, we do have other way as well. I mean, we can call Apex method imperatively and get data. I'm thinking to create a separate video to explain in what all scenarios we should call method using wire decorator or when we should call method imperatively. Initially I planned to cover in this video only, but due to the video's length, I'll create a separate video to provide a more detailed explanation on this particular topic. Okay. Now, if we talk about why we should use wire decorator to read data, Then in detail, we will discuss this question in a separate. But if we talk about main reasons which I can think of, then first is Wire Decorator is a reactive service. Here reactive means whenever data gets changed in LDS case, then Wire Decorator will automatically update that data in component as well. We'll explain more this point in LDS video, Lightning Data Services video. Okay? And next is Wire Decorator stores response in client-side case, which means whatever response Wire Decorator gets from an Apex method or LDS adapter, that response gets stored in client-side case. Here client-side means whoever is using our application or whoever is going to call method, for example our browsers. So it means when we call a method using Wire Decorator from our browser, then its response will store in our browser case. Now due to this behavior, application runtime performance will increase. How? By reducing server round trips. I mean next time, framework will not make server request and return data from client-side case only. Let me explain with you a diagram how Wire Decorator internally works with case and how it can help to improve component performance. So when a Wire Decorator makes a request from component, then first that request will go to framework. Now here, first framework will check that is data available in client-side case. I mean if you are using our browser, then framework will check in our browser case that is data available here. If yes, then it will return data to framework and our request will be fulfilled from here only. I mean framework will not make server request. And in case if data is not available in client-side case, and then framework will make a request to server, and then whenever framework will get data, then first it will store that data into client-side case. After that it will return to component. Okay? So whenever we load our component first time in browser, then obviously data will not available here in client-side case. So in that case, framework will make a request to server and get data and store that data into client-side case. Now next time from that same client or from that same browser, if any component make request on that same URL with same parameters, then data will be returned from client-side case only, or we can say from our browser only, which means no need to go to server again and again. So that's why we can say if we use Wire Decorator to read data, then our component performance will be better. We'll explain more this point in wire versus imperative video. Alright. Now let's jump into second part of this video and start looking into interview questions related to decorators. Though most of the questions we have already covered during explanation, but still let's see all the questions again and start with first and very basic question, that is what are decorators in LWC? So we can say decorators are a special type of functions that add some superpower to an existing method and property without directly modifying the original code. If you want to explain more over here, then you can explain whatever we have discussed during explanation. Okay. Next question we have, how many decorators we have in LWC? Then answer is 3, Drag, API and Wire. And next question we have, can we create our own custom decorators in LWC? Then answer is no, this is not allowed. Okay. Next question is, what is the use of Drag Decorator? So simply answer is to make properties reactive, so changes can be automatically observed and notified. Next question we have, what is the use of API Decorator? Then we can say to make properties and methods as public, so they can be accessed out of the component. And API Decorator also makes properties reactive, which means we don't need to add Drag Decorator externally. Okay. Next question we have, what is the use of Wire Decorator? So as discussed, using Wire Decorator, we can read data from Salesforce servers by calling Apex methods or LDS adapters. And also, properties declared with Wire Decorator also work as reactive. Alright. Next question we have, can we add multiple decorators with a property or with method? Then answer is no, that is not allowed. Now next question we have, which decorator can help us to pass data from parent component to child? Then answer will be API Decorator. Okay. Next question we have, can we manually call wired method or property? Then answer is no, we can't call wired methods or properties by ourselves. Framework will automatically call them when component connect with DOM and when dynamic parameter value change. Okay, so we can say we don't have any direct option to call wired methods or properties like on button click or on any other action. But if we have such kind of requirement, like let's say you want to call a wire method on button click, then in that case what you can do? You can just change dynamic parameter value as we have changed in our search button click handler. So then framework will automatically call wire method again. Okay. Next question we have, can we chain wire decorators? Here chain means can we call one wire decorator after another? The answer will be yes. How? So let's say we have a requirement to get picklist data in LWC component. Then obviously we will use get picklist values wired adapter, which is available in LDS. But this adapter requires a record type ID. And if you want to get record type ID of an object, then you have to call another wired adapter, that is get object info, which means this wire decorator is dependent on first one. Now what you want? You want to get record type ID from this method and pass that record type ID here, which means whenever this wired property get data, then you want to call this method again and fetch data according to record type ID. So in this case what you can do? You can simply pass parameter as dynamic parameter by adding $. So now what will happen? Whenever we'll get data in this property, then framework will automatically call this method again. Okay. So this is how using dynamic parameters we can chain wire decorators in LWC. Okay. Next question we have, what is the criteria for an apex method to be called through wire decorator? So we can say, first of all, a method should be public and static and marked caseable equals to true with or enabled annotation. Okay. Then only we can call a apex method through wire decorator. Next question we have, can we perform DML operations inside a caseable true method? Then answer is no. We can't mutate data in caseable true method. We can perform only read operations. I mean, we can only read data from caseable true method if we are calling it through client-side frameworks like from Aura and LWC. And if we try to perform DML operations inside a caseable true method, then we will get too many DML statements, one exception. Okay. But I would like to highlight one point here, that we can perform DML operations through caseable true method as well. But the condition is if we call that method through apex or execute anonymous window. That is not allowed only if we call it through client-side frameworks like from Aura or LWC. But if we call that method from an apex class or execute anonymous window, then we can perform DML operations as well. Okay. Next question is how to replace client-side case data in LWC. So as discussed, if we use wire decorator to read data, then our data will store into client-side cache. And for subsequent request, we will get data from cache only. Now let's say anyhow those records has been changed at server side, but in our cache, still we have old records. And if we try to get those records again, then also we will get older records because framework will return data from cache only, right? Now the question is how we can avoid this problem or how we can refresh client-side cache. So in that case what we can do? Either we can use refresh apex method or we can use notify record update available method. We'll explain more about these methods in coming videos. Okay. Next question we have, which runs first, wire decorator or connected callback? So as discussed, just after constructor, first wire decorator will call and then connected callback will get called. And again, after rendered callback or whenever wire decorator gets data, then it will call again with data. So we can say first wire decorator get call, then connected callback, then wire decorator call again. Okay. Next we have wire versus imperative apex. So as I said, we will cover this topic in a separate video because this is a very important and long topic, and you know this video already become too long, so we'll create a separate detailed video on this topic. Okay. So that's it in this video where I tried to explain all the decorators in detail with interview questions. If this video helped you to learn something new, then please help me to by like and subscribe my YouTube channel and also share your feedback in comments. Thank you so much for watching. We'll see you in next video.